Hello and welcome back. So here we have another truss analysis question, and we are required to calculate the reactions at supports A and B. Now A is a roller joint, so it only has one force that is perpendicular to the joint. So in this case, it's going to go straight up, and we'll call that a Y. And B, we have a pin joint, so it's going to have two forces, one vertical and one horizontal. So we'll call this BX and we'll call this BY. Alright, now another key piece of information is this drawn to scale business. That means you need to use a ruler to measure the length of these members and a protractor to measure the angles if required. So by using the ruler, you end up getting 40 mils for this member, 20 millimeters for this member, and for all the remaining members, and this is also 20. So all the members are 20 millimeters except for that first one, which is 40 millimeters, and this member M, which is another length, but that's not important. So now that we've labeled it, we can now go ahead and use our equations. So first thing first, let's do some moments about point A. You can do about point B, that's no issue. And I'm going to take anti-clockwise as positive. So I've got this 54 kilonewton force, so 54. I'm going to keep my forces in kilonewtons and my lengths in meters. Now you can keep them in millimeters and you still get the same answer. So we've got 54 times its perpendicular distance to A. So we've got this 40 mils plus this 20 plus this 20. So that's 80 millimeters. Convert that to meters, you get 0.08. And that's going anti-clockwise, so it's positive. Then I have this 75 kilonewton force right here. And that's going to be multiplied by, so that's going clockwise, so it's negative 75 times this distance and this distance to A. So we have 75 times 40 mils, which is 0.04 meters. Then I have this 27 kilonewton force times its perpendicular distance, which is, this is 20 and this is another 20. And it's going in the anti-clockwise direction, because you can see it rotate about point A like that. So it's going in an anti-clockwise direction, and that's plus 27 times perpendicular distance, which is 40 millimeters, and that's also 0.04 meters. We then have BY, which also produces a moment about A. So BY times that distance to A, which is 20 mils, and that's 0.02 equal to 0. Now, BX does not create a moment about A because it goes through the joint A, hence no perpendicular distance. Likewise with AY. So now that we've got our equation, we can now just apply simple mathematics and solve BY, and you get 0.02 BY equal to minus 2.4. So BY is equal to 120 kilonewtons. That's negative. But we have assumed BY to go up. Now, because it's a negative, that means BY is actually going downwards. So that's equal to 120 kilonewtons going down. So now that I've applied sum of moments once, the next step is to apply sum of forces in both the X and Y direction to find the remaining support reactions. So now we have sum of forces in the vertical direction is equal to 0, and I'm taking up as positive. So I've got that 54 kilonewtons going down, so that's negative 54. 75 kilonewtons going down, so that's minus 75 plus AY. We've got BY going down, so that's minus 120, and that's equal to 0. So that's all the forces going in the vertical direction. So do your maths and you get AY is equal to 249 kilonewtons, and it's positive, so our direction is correct, and that's up. Now that I've done that, I now do sum of forces in the X direction, or in the horizontal direction, and we'll consider this as positive. So in this problem, we only have two horizontal forces. We've got this 27 kilonewtons that's going to the left, so it's negative 27 plus our BX, which is going to the right, equals to 0. So BX is equal to 27 kilonewtons, and that's going to the right. So now that I've got my BX and my BY, I now need to apply my vector triangle, where I can find my resultant force and my direction or my angle. Okay, so we have By going downwards at 120 kilonewtons. We have Bx going to the right at 27 kilonewtons. And this is our resultant. Remember, your resultant is always tail, tail, and head, head. That's my R. Now to calculate the resultant, you just simply apply Pythagoras. So R is equal to square root 27 squared plus 120 squared. And that gives you a value of 123 kilonewtons. And my angle is, this is the angle that I want to find. And you simply apply tan. So theta is equal to tan inverse opposite over adjacent. So 120 over 27, which is equal to 77 or approximately 77 degrees. So your final reaction at B will be 123 kilonewtons at an angle of 77 degrees below the horizontal. Now in the answers, they've done the angle differently, but in most cases, and especially in this case, we look at the angles below the horizontal and above the horizontal. So this answer will definitely suffice. Also, they have incorrectly given the angle at reaction A to be 0 degrees, when in fact it is 90 degrees, because the force is always acting at 90-degree angle to the joint. The reaction at A is equal to 249 kilonewtons, and we'll write this down at 90 degrees. And the reaction at B is 123 kilonewtons at 77 degrees below the horizontal. So to sum up, we drew our reaction forces on the diagram. So you got your AY roller joint, BY and your BX for your pin joint. It's drawn to scale, so measure the length of the members. Then apply some moments about A or B, either one is correct. If you apply some moments about A, you get your BY reaction. Once that's done, apply some forces in both the vertical and horizontal to get your AY and your BX. Once you've got your BX and your BY, you can then form a vector triangle, making sure that your resultant is always tail, tail, head, head. Use the Pythagoras theorem to calculate your resultant, then use tan to find the angle, and then that's your solution.